presentation, but I just like to start like that. So thank you everyone for coming all this way to hear me out, and thank you to ManyChat for inviting me. So a little bit about myself. I am a software developer. I have been a software developer for, well, many more years than I like to remember. Most of my career I've been teaching people how to develop software, and that's kind of what I do right now. Specifically with PHP, I've been doing it for almost 20 years now, so that's quite a bit. And specifically today I work mostly as a consultant and technical coach, so we can discuss that later on. So the topic for today is dealing with long-running processes, the Symfony way. So it's funny because I didn't know this when I put together the presentation, but it's kind of a, I want to say, a complement to the previous presentation, where I'm going to try to talk about the flip side of the performance issues, if you will. Let's see how it goes. So first of all, how many of you use Symfony on a regular basis? Cool. Kudos to you. Okay, so those who don't, I hope you will feel differently after the talk, because I really think it's really cool. And I am not biased in any way, as you can see. So let's get started. So the idea is, what happens when your application has to deal with really long running processes? Sometimes things simply take time, and there's not really any way around it. Let me give you a few examples that I found in my professional career. So the first one, import financial transactions from several Excel files. This is actually the example that kind of gave birth to this idea of the talk I'm going to share with you. It's a really simple scenario. This company, they have a very big reports they need to consolidate and upload on a regular basis, and there's no way to chop the reports or do any other thing. They just need everything in place. Another situation that you might find is download the latest geomap definition. Now, do you know what geomap is? Okay, cool. What else? I don't know, maybe prepare last year's sales report. These are simply things that will take time, mostly because the data volumes are kind of huge. So what happens when we face such a situation? On the, let's say, the best possible scenario is we will get bored users, okay? Because really, who among you likes to wait around for things to happen? Yay. Okay. So anyway, and this is the good situation that we might find. On the opposite side of the spectrum, we might find something like this, which is a 500 error because of timeout. I guess because of the smiles, I guess everybody knows what I'm talking about. And in particular, PHP has built in sort of I would say, safety mechanism to kill every script that is misbehaved in terms of time consumption. Everybody must have seen max execution time, 30 seconds is the default usually. And that makes a lot of sense actually when you're in a, let's say, like a shared hosting environment. You don't want to penalize your neighbors because of your own bad behavior, okay? But there are situations where you simply need more time, okay? So, this is something you've all been thinking about it. Don't tell me otherwise. Okay, yeah. Of course, in theory, we can do this, but again, what we are doing here is we are breaking the brakes. So it's not really a very good idea. But don't worry, there is a solution for you, and bear with me for a second. So the solution, and I'm going to do a little run through the concepts before we look at the code and everything, so just bear with me. There will be code, and I will actually perform a live demo, which I hope will work. But the idea is simply to decouple. Okay, that's the main topic here, is to decouple. And what exactly are we trying to decouple? Okay, so I'm going to skip this one, but what I'm trying to say is to decouple the response to the user from the actual processing. Okay, because there is in a way, we are going to trick the user. Okay, because there is no way around it. That's the premise of the whole thing. Is the process will take long. Deal with it. No way around it. You can optimize it wherever or as much as you can, but it's still going to take too much time. So what we are trying to do is not to have the user like hanging there waiting for this long process to finish. Okay. So this is basically the idea of how this is going to work. So we will have sorry. Okay, so this is our server. Then that's the user. So what they will do is they will start a process, and immediately they will get a response back, which says, "Okay, your process is started." All right. It doesn't mean it's finished, of course, because it takes a long time. But what we're going to do is process it on the background. Okay. So the user can keep doing their thing while the process is running. And once it's finished, they will get a notification saying, "Hey, remember that thing you asked me for a while ago? Here it is." Okay? That's the idea. Well, in the middle, we'll have a queue. In this case, it's going to be stored in a database, just for simplicity. But you can go as crazy as you want here and use a RabbitMQ or whatever other queuing mechanism. It doesn't really make a difference. One very important aspect is and that's why I draw it this way, I hope it makes sense, is the existence of two separate, let's say, not necessarily servers, but computing, let's say, processes, okay? This is very, very important. You will have one process which will be in charge of simply attending users and responding to requests, and another one specially dedicated to processing the background stuff. Okay, that's kind of the gist of it. And that way, we can keep the user happy, and also we can keep the server happy, if such a thing is possible. All right, so let's go see what's behind the magic. Okay, so these are a couple of my friends, which I'm going to be introducing to you now. I know maybe you are familiar with them. Perhaps somebody else? Okay. So I'm going to start with describing. This one is actually something I recently brought into my own project, which is a simple kind of a message broker. Maybe not. How would you describe it?
More like combined the message broker and web server included, so it's a big thing for long polling, HTTP3 stuff, and etc. So when you can interact with users
Okay.
for a long time.
All right, fair enough. So I'm going to use it as a message broker in the sense that it's going to be an intermediary between my backend and my frontend or my users. I think that's probably a better description. Well, JavaScript, I think it doesn't really need much introduction. Doctrine, for those of you who are not familiar with it, is the default ORM used in Symfony projects. I personally like it very much. I used some others, and I really like Doctrine. And then again, Doctrine in this little scenario is kind of an accident in the sense that that's because I'm using a database as a backend, but I am using Doctrine to access the database. Okay, if I used any other backend, there would probably be no use for Doctrine. But the real star of the show is the messenger from Symfony, and that is the component that will actually do all the heavy lifting. So let's see. I'm going to quickly run you through how this looks a little more lower level. So this is the first request that the user will issue. So they get some HTML back. There's no surprise here. Then the first thing that they will do is they will subscribe to this Mercure server. So they will say something like, hey, I want to be notified when something happens there. And then some other later time, they will start this long process, like hey, upload this file for me. And that's the idea. Like, upload this very big file and let me know once it's done. Because I want to go about my business while you process that. Then the Symfony component will insert a new message in the queue, in the message queue, and return some JSON back to the user, to the client, saying your process has been started. Okay, it's pretty much the same that we saw earlier, just a little bit more lower level. And eventually, this little clock would be a cron job, okay, something that will spawn a process to, well, actually, a request to consume messages to this little one. And it will, this little server, let's say the helper server, will look for the unattended messages, bring them back, and try to do something with them, hopefully something useful. And, well, that's what the handle message will be. Eventually, it will say, I have some news about this process. Okay? We will publish the news to the Mercure server. And if you remember a little bit ago, we said that the client was subscribed to the Mercure server. Okay? So when this is published, Mercure will simply broadcast this message to everyone who has subscribed to it. And you will notify the user, and they will know that something has happened. Okay, so far so good? Great. So you want to see some code, maybe? All right. Okay, so I was hoping to show you some of them on my ID, but I think it's going to be easier to go here. I'm not going to go into the whole thing. It's going to be very, very tedious. But I just wanted to show you a little bit. For those who know Symfony, so this first line that says root/long/process, that is the mapping between the URL and the actual controller that will serve this request. So at the very start, it will simply do like this. It will render a template that will be the HTML that will be sent back to the user. Okay? And at some point, there is, as you can see, there is this other URL /start, which will, well, start the long process. Okay? Perhaps let me alter the order. I will try to show you what this looks like before we see the code. So this is the website, let's say, that I wanted to show you. So let's say I'm doing something. This is the user area, and that area over there is going to be for notifications on what's going on behind the scenes. So let's see, before starting the process. Okay, so I'm just doing stuff. Okay, at some point, I decide to start this long process. Okay, and I got this response saying the process has been queued. Okay, so let's continue. As you can see, nothing's really happening. Okay, and that actually makes a lot of sense because I never really started the consumer. Okay, so in order to simulate what I said earlier, the clock and the cron job and everything, I'm going to just start the consumer, and now you can see that something is appearing here, telling me how my process is doing. More stuff, more. So the code, as I'm going to show you in a little bit, is all, it's not really doing anything, but it's outputting random progress metrics to really simulate an actual long-running process. But so this is the idea. I just want to run it again to show you a little bit more of this. And I want to take advantage of the, it did actually run, so I'm happy about it. So this I'm showing you is the contents at every moment, the contents of the queue. All right, this is a table in the database. That's the way Doctrine will output the contents of the queue. Okay, but eventually the queue has been empty because of because the consumer is running all the time. Okay, cool. Come on. I put a lot of work into this, so I'm really glad it works. So okay, now we can go back to the code, and as I was saying, the index is very simple. It returns the very first page that you saw, the HTML, without any more things. And here it returns a JSON response telling the client that the process has been queued. Okay? So this is really nothing very special. The really interesting thing is this one, where it says that this is dispatching a message. Okay? This is where the Symfony Messenger comes to play. As you can see, this is, message bus interface is a collaborator that I have to inject into the long process controller, okay, for it to be available for me at this point. All right? And what it will do, this will simply say, okay, I will show you this start process message in a little bit, but the idea is it will take this this instance of the start process message and dispatch it. And what does it mean, dispatch it? It will simply input a new record into the queue. Okay, so this, what you're seeing here is the code, let's say, well, it's a part, but it's the code for the web server. All right, this is dealing directly with the user. Okay, cool. So here we have what it is, the messages, very, not much to it in this instance. It's simply about starting the process. This is the way that Symfony works. Let's say, well, actually, Messenger. So we have these messages. In this case, the finished process is exactly the same. You know, it's just a message. I don't need to really do anything about it. This one is a little bit more interesting because it's the intermediate message. Like, hey, some progress has been made. Okay, you could, if you want, and I actually challenge you to do it, you could take the code that I'm showing you and draw a very nice progress bar if you want to. The information is there. I just didn't have time to do it, but you can do it much more visually. And this is the idea. Every time some progress is made, there will be a construction of a make progress message with what's the current percentage. Okay, and that is what will be eventually output back to the user. All right? Any questions so far? Cool. All right. So on the other hand, we have the message handlers. Okay. So this is really interesting. Is every message needs a message handler to be available, and the connection between them is done through this. The invoke method. Okay, this is the magic method that kind of turns a class, or actually an object, into a function. Okay, so it will be invoked every time there is the need to process a message of this particular type. Okay, so let's look at this. What is happening when the start process message handler is invoked? Well, it's simple. It says, I will issue the new message. Okay, so that's kind of, it will be creating like a message chain. Okay, every time I process a message, I will issue a new one until the end. So I start with saying I am a process completely 0, and this is what I do here. So this is, I am dispatching a message to the messenger bus, to the queue. Okay, and this second sentence, let's say, is actually the one that is building the communication through the Mercure hub. Okay, so this is the thing that will be sent back to the user when Mercure decides to. Okay, so you see there are two lines of communication. This one is internal through the messenger through the message bus, and this one is to be sent to the user. Okay. So this thing is to determine, the first parameter is to determine like the channel, because this communication can be pretty complex. In this case, I'm using just a single channel. It's a simple communication. So this we're seeing is the make progress, message handler. So it's the same. It's the code that will deal with the situation where a message called make progress message is found on the queue and needs to be consumed. All right? And when that happens, this is exactly what I was saying. It will simply sleep for a random, from 1 to 3 seconds. Of course, in a real scenario, that it's not what is supposed to happen, but rather to actually do something useful with the time. And then it will again increase the percentage by a random number. Okay, so but eventually it should get to 100. Okay, so as you can see here is what is the next message to be sent. Is either if we are below 100%, then we need to make further progress, and otherwise, that's okay, and we need to signal that the process has ended. All right? Cool. Then once the process is finished, we need to inform the user of that situation for them to go on with their lives or do whatever they were hoping to achieve. Okay, here we have the front-end side of things. What you're seeing here, for those of you who might never have seen this is a Twig template. Twig is the template engine mostly used within Symfony, but it's basically just, it could be HTML. I just stripped the HTML parts because I didn't really find them particularly interesting. But here what you're seeing is the JavaScript code that kind of glues everything together. Okay, so this will be executed at the start of the on page load. Let's say this is very important. This is the connection to the Mercure server. It's the actual subscription, and these are the functions that will be called every time a new event has been received. From here is this is to connect to the server, and this is it will be the callback that I'm going to use every time an event is received on the front end side. Okay, and this function is simply what to do when the user clicks the start button. Okay, so the demo that I just ran is a little bit updated, respecting to the code that I'm showing you, but very slightly for doing a little UI improvements. Nothing big. So this is a very important part. I just showed you what was going on, when the messenger consume part was run and when it wasn't run. Particularly when it wasn't run, nothing happens. Okay, if the consumer is never invoked, the messages will simply be, collecting dust in the queue, and nothing will happen. All right. So it's very important that at some point this invocation is done. Okay, you can have it running eternally, as I did on the presentation a couple of minutes ago, or you can do it on a regular basis via cron job or something like that. It's fine. And this modifier is simply to have the messenger actually show you what's going on. You don't really need it in a real scenario. Okay. Is everybody with me? Okay, cool. So a little word of caution I want to give you. Very important. The messenger consume, as many other long-running processes within PHP, ironically, that's what we're talking about, can be extremely resource-consuming. Okay, there are some problems within or there might be some problems within the PHP core where memory is not correctly deallocated, or very bad things can happen. Let's say if you leave the messenger running on its own. So there are a few tricks that you can do to limit its damaging power, or actually to keep it on the good side, which are this. little modifiers that you can do is you can limit the amount of messages being consumed at every attempt. You can limit you can put a threshold, upper threshold to the limit to the memory that it can be allocated, or you can do a time limit, okay? Maybe in some extreme cases you want to use all three at the same time. I don't know, okay, so there is somebody here saying it is, okay. I'm not sure I actually used all of them, but you know, they're there for a reason. So, you know, use them or don't use it at your own peril. And okay, so I think that's pretty much everything I wanted to show you today. It was shorter than I, than I anticipated, but.